logical data model and relational algebra a bit. We're going to extend that today and touch upon databases and SQL and how to do SQL, right? And we'll take a look at an example in MySQL. This is a completely hands-on session. I'll be sharing my screen in a minute and we'll look at how MySQL works and probably also install a new database, create a sample database and set the data up, create the tables up and all of that. And then we'll insert a lot of data files into that and eventually we'll try and look at some querying, all right? So that's the whole objective for today's session. We will start the session in 1 minute probably. Just allow me a while to set few things up on my side. I'm running a little late today. What is this in my eye? Okay, I have no clue what is happening. Oh, okay. The light is causing some sort of reflection. Yeah, it should be better. Cool. So we'll just wait for a couple of people to join and then get started. Meanwhile, I'll share the links that we need to be looking at today. All right. So the first thing that I have is that I have my database set up. This is a MySQL installation, as you can see, and I have SQL Workbench, and I'll quickly talk about how to use SQL Workbench. Right, that's the first thing we'll touch upon. So to begin, this is the database. This is the MySQL database. This is I've already downloaded it. I'm gonna post a new video on how to install SQL and how to install SQL Workbench in Windows 10. Just watch out for that video. It should be out by tomorrow, end of the day. All right. And the second thing which I've done is I've downloaded a database called Sakila database, which is just here. Okay, let's just, yeah. So just to, again, for people who are new to databases, I'm gonna point them out in chat and give them the links about the database. So here's the first link which you can use to download the database. Just click here, go to community, and you will find all the things here. So the first is MySQL installer, and this is MySQL installer, right? MySQL installer, and then there is SQL Workbench, which you can also install on your own machine. Workbench, all right. Yeah, so these two are the tools that you will need to kind of work with the database. And then what I've done is I've downloaded this database, which is called Sakila database, as I mentioned. Here's the link for that database too. The way to install this is you need to go to a link and just click on this link where it says it's available and download this zip file, right? Or if you're on Windows, download the zip file. If you're on Linux, download the tar file, right? That could just help you out with respect to getting a zipped version of it, right? And the way it looks is it will download as a zip in your machine, and you can probably see here that you get 3 files, right? There are 3 files that you get. The first file is an MWB file, and we'll look at how to import that in SQL Workbench. This is the logical schema of the database. The second file, or rather the third file, is the schema, which will talk about what the database schema is. And this is basically needed to create the database, and we'll look at what is inside. And last, the third file that you have, the .sql file, this is the actual data. This has all the insert scripts that you need to be able to learn the database, all right, to be able to learn querying, all right. So that's what is needed, and you can download from the links which I have previously pointed out. All right. What happened? I think I got a Windows restart. Yeah, sorry, Windows glitch. Just a second. All right, no harm. SQL Workbench is still here. Okay. So what we have done is I have all you need to do is the step one is let's just remove this. So the first thing to do is let's look at the database model file. So the structure for the course, the structure that we are going to be taking is, let's just see a whiteboard quickly. I'll just open a whiteboard too. All right, so we will start with logical, right, schema. Then we will create the database using SQL, and I'll show you all the commands how to do that very quickly using SQL. Then we will create tables again using SQL. There's no other way to create tables. And then we will do select queries, a lot of them with joins, inserts, updates, views, etc. Right? So this is a whole database lecture. Just stay tuned and put in questions in the chat if you have anything that you want to talk about specifically. All right. So that's the overall agenda for the session. We are going to be talking about a lot of these stuff. Logical schema, create the database, create tables, and then the queries and the joins. So just hang on tight. So the first thing, as I mentioned, is we'll do at the logical model. So we will pull the MWB file, which is MySQL Workbench file. Opening another model will close. Okay, sure. So this is the MWB file, which is the logical schema of the model. Now, if you're from college, most of you would have been taught about logical schema and relational models. This is an actual table. This is the physical representation of the database. So we will quickly take a look at what is this database about and how do we understand it. Now, there's a language table, but let's just focus on the key tables, right? There's a film table where you have a key column. There are, let's look at, just a second. Why does it not open? There seems to be some slowness happening, but never mind. I'm not gonna, yeah, okay. It moved. It's just a little slow. So just close this. Never mind. I'm not gonna do that operation. It just ends up hanging it. So film is the table, and if you see, if I just hover over it, it changes the color. I might want to zoom this further. Right. So film is the table, and if I just hover over it, kind of changes the color. It's not doing. Yeah, it's doing sometimes not doing. Never mind. So it's just highlighting the relationship also. It's showing me that the language ID is connected and the original language is somewhere else. And then the film category is also coming from a different table. So every time I show a table, I hover over a table, right? In green, it is showing me where it is related to. All right. The primary key is up top, which is film ID for this, film category ID for this. And then you have actor, addresses, store information, inventory information. Now, this database is basically the database of a movie rental store. So the idea is you have films, you have addresses for the film where the customer address is, and then you have other tables like city, film category, payment, country, actor, rental information, customer information, and all those sorts of good stuff, right? So this is a logical schema. It shows you about relationship where you have a triangle or a three fork going out. It shows many to one relationship or vice versa, one to many relationship and things like that. Okay. So this is the logical schema, and based on this, the tables have been created. Now the next thing to do is just go to MySQL and double click. I've already done that. So you will end up with something like this, which will have a sys table. Now the first file, which was this file, which we downloaded and I just showed some time back in the original, in the start of the session, right? This is the SQL file. This is where your, this file, the third file is where your SQL schema is, where the create structure is, right? How do you get the file? You just download from the link I've given. Now we are going to be taking a look at all the the queries part of it, and we'll take a look at how the queries have been written and just understand the key structures around it. Just want to increase the font a bit. Let's see if the universal approach works. Okay, it does not work. Where is it? View, query, font. I am not so familiar. There must be a way to just increase the font. Usually, let's see, preferences, object editor, SQL, query editor. No, I don't seem to be. Okay, font and colors. SQL editor. Let's make this 14. Let's see if this ends up in any changes. Okay. Just bear with me for a few seconds. This is relatively. Wow, it crashed. Not a good thing. Just a second. I will quit my whiteboard and open Workbench again. Not a good thing to happen. Just bear with me for a moment. I will again open this. Yeah, I just opened in the same font. I am just hoping it is visible. Let me probably try to move my picture somewhere up. Does this work any better? Can somebody give me a feedback if the text is visible to you guys? Quickly while I try to, I'm sorry, I did not think this through. System default. Let's just try once again. One last try. Okay. Easier option. Okay, perfect. Thanks. So we will just, this was easy. Just select and scroll up, this works. So we'll just walk through the key structures, and the first thing that you see is the drop statement, right? In when you work in a production database, right, it's a good practice to evaluate if the table already exists. So if before create statement, the idea is you drop it if it exists, so that you don't end up into any sort of queries that are hitting or queries that are running, right? So you do a drop schema, and then you create the schema Sakila, right, which is what is this is, and then you specify use Sakila, which is we'll start using this database for our purposes for next query. And then what we have is the table structures. Now the way to go about table structures is there's a create statement, which is create table name. Table is the keyword, table name actor, right? So actor is the name of the table here, which is what we saw in the relational model, right? Then you have actor ID, which, and then you have small int, right? Then you have an actor ID, and then you have the what do you say, the data type of it, right? The varchar, the integer, char, numeric, boolean, blob, clob, all of that. So you have the data type, then you have whether it is signed or not signed. It is set to not null, which it means it's not a column which can be null. There can be no null values. And you have set it to auto increment, which is like it's going to constantly keep on increasing as new records are getting added. So this is something you don't have to insert numbers around, right? Then you have first name, last name, update date, where you are capturing the timestamp. Primary key is the key which is used to uniquely identify a record, or in this case, primary index also, which is the actor ID, which is same as the key here. And then there are certain additional keys that we have indexed on last name also for whatsoever reasons. There are certain engines which we can safely ignore. The engine is INODB engine, which tells MySQL to what DB engine to use. And the char set is UTF-8. Similarly, there are other tables being created, which is like create address table. Different tables are getting created, right? You have address ID, you have address district, city ID, postal code, a lot of stuff, right? And then you have other cities for other tables, for instance, city table, country table, which is again this table. And then slowly and eventually, as you finish this, right, as you finish doing the table create part, then what we have done is we start to create triggers, right? Triggers are something that uh, you want to insert into multiple tables at the same time. For example, let's say that there is a table created wherein every time after insert on film, for each row begin insert into film text. So every time a new record is created into the table film, you take certain values from that, for example, film ID and title from the film table, and put it into a different table altogether, right? This is a more of database, which is like just design the moving gears. Then there are certain update scenarios, there are certain delete scenarios that you have put. Okay, so similar, when you create a table, it's a very good practice to define the corresponding triggers and set the conditions accordingly. Like for example, table A is created, and when a new record is created in table A corresponding change happens in a certain table B, depending on certain fields in table A, which is what was demonstrated. All right. So then you have different tables like language table, payment table, rental table, and this is a very large structure of table. We can go and take a look. And towards the end, right, couple of standard views are getting created. Now, what are views? Views are queries which you simply want to run over and over again. So if we were to think of what do we say, a database, right? A database actually stores the data, physically stores the data. But a view is the result set of a query, right? Which you want to run over and over again, but you don't want to persist the data all the time. So the data is not persisted. A view does not actually hold the data, but it just holds the query. So a view is fired every time you want to see something, and you would do this for all common purposes, right? For example, I want to see certain information for my customers, right? I want to see their names, numbers, city information, address, and the data is stored across tables, right? For example, country is stored in a country table, city is stored in a city table, and you want to do all of that and get it in a single nice little report. So you would create a view for that. Sometimes a relatively advanced concept is you have something called as a materialized view. What does it mean? When you have a view which you are running over and over again, it still goes back and executes the query in real time in the database. A materialized view actually replicates the data. It basically gets the data from the database and stores the results separately. So this is a view, but just the results of that query, right? And again, the idea, why would you use it? You would want to pre-compute certain information, right? And store certain aggregates beforehand instead of just doing it on the fly in a reporting scenario. So those sort of things help us with materialized views and views. All right, so this is the view stuff. There's a lot of views created in this. You can just go one by one in order and just take a look at it. All right. And that's pretty much it what we have in this query, in the create schema query, right? The next query is basically insert data, right? And this is a very simple query table. All you will find is a lot of values for each of them. I'm not going to get into that, but the way you do is you have all the insert statement returns that are needed for the database and you just run them. So I have run these two. For instance, I can just run it right away also. Once I run it, it's gonna just drop it. As you can see, it just dropped it. And if I just refresh it, it's probably coming back again, right? So it just created everything and dropped and recreated everything. Now what I need to do is, if you see that there's about 46 operation. Now I will stop. Just run this again. Right, so all the records are getting inserted in the database, right? It's all the queries have been affected. Just to check, I'm going to fire a query before going in the whole depth of what queries we want to run, right? So just to check, we will do a simple query where I'm selecting film and I'm getting the title of the film and category dot name by joining from two different tables. The first table is the film table and the second is the category table, right? So we are joining on two tables and there is a category ID on which they are joined. All right, in this, and I'm getting the title and a name. So it means my records have been inserted, right? So we'll quickly start with this and I'm going to take step by step and I will run each query one at a time just to be able to explain through some of the queries in detail. Now, some of the most basic things in databases, or one of the most basic and foundational things in databases, are to understand how a select query is structured, right? So we'll start with this. We'll just call use Sakila, which means that from this point in time onwards, you can use this database. The first query is just going to get me the name, first name and last name of the actors, right? Now, something to notice, I have written select first name, comma, let's just find a way to make this small. Yeah, I've just written select first name, comma, last name from actor, which is table name. If I want to change from first name to something else, let's say F name, right? So I don't want to call it first name. I want to give it some other name. Now this becomes an alias, which means that F name is an alias. However, the first name is still the column name. And this you would need if you want to change the name or if you're sending a report where you need a nice naming convention and things like that. So this is just how you create an alias. So as is a keyword which can help you create alias, and select column name, two columns separated by comma from table name. The simplest and the most basic of queries. All right, so I'm just going to leave it at that and run it. Now the next thing that I want to do is, let me just hide certain things. Now the next thing which I want to do is display the first name and the last name of each actor in a single column and get it in uppercase, right? And I want to call the column as an actor, right? It's an actor name. It means that I want to give an alias, and this is just another way of doing an alias in MySQL, right? So I will run this, and if we just see the breakup of the query, what I've done is I've used the word concatenate, which is a function which operates on columns, right? So concat will take column 1 and then second space. I wanted to have a separation, right? Some space, because otherwise they'll just stick together. So I've just put comma, comma, and just put a space in between. This is basically a character which I've inserted between them. This becomes a column in itself, right? And then I have taken the last name and again put them in a function called upper, which means everything will be concatenated and the upward case of that will come, right? If I do not do this, let's see what happens then, right? It's going to give me the whole operation and this looks pretty dirty, right? So I'll just put this back and let's see what it gives me. It's going to change it and consider it as an alias. So this is another way of doing an alias. Okay. Now, but what we have moved is we have looked at alias, we have looked at a function. Now we will look at a where condition, which is where the fun starts in database, right? Now I need to find the ID number, first name, last name of the actor who has the name Joe, all right, whose last name is Joe, which is why we created the index in the actor table with name, last name. So let's see. So we will have actor ID, select actor ID, first name, last name, which is what we mentioned here. Most of the time, the trick to writing a correct query is you will get the question itself will lay out what should be in your select. If it is not a direct column name, then a lot of times you can assume it will be some sort of a derivative or subquery or derived column. So here it's very simple. ID, first name and last name, ID, first name and last name from the actor table. But I only want people who has names with Joe in it, right? The last name is Joe. There's nobody, which is weird. There should be somebody, but I do not know. There is null here, which seems to be weird. Okay, first name is supposed to be Joe. Okay, so this is first name is Joe, and there's one person which has Joe Swank is the name, and we have just taken the lower because just to match the cases. All right, my mistake. I took it last name. It's the first name. Right. Next, what we want to learn is try to do search in databases, and this is a very powerful query to understand because searches are very common. You need to find patterns in data, right? So if I want to find everyone whose name has Jen, right? Let's just change this to this. And if you see, Jen means the percentage before and after means any combination of the word Jen, which whether it comes from the beginning, comes from the end, it will be there. For example, this guy has Jen towards the end, there's Jen in the middle, Jen in the middle, and things like that, right? Now we could change this to, let's say, our Joe problem, and let's see what we get. None. Maybe we want to see lower. None. Okay. I think I used the keyword incorrectly. Let's just change this to. And we are also using the like keyword. That's also something which I wanted to point out. And let's just see if we get that. Yeah, you see we got the same result. So we got Joe Swank. So the queries are relatively similar, but the first one looks for an exact match. The second one looks for a pattern. And the way it looks for a pattern is anything comes before and after, and this was a relatively easy match, hence it was able to get me that answer. All right. So we have looked at how to get pattern matching up and running. Next, we'll find all actors whose name contains the letter LI. And this time we need to order them, right? Order them alphabetically. Usually a key to understanding SQL interview questions or exam questions are the ordering information is the absolute last thing that the question itself will ask you. Advanced question might not offer you this complexity, but usually the questions that are framed are written in a way to explain the first part of the question will be the select, and then in between the where condition and the nested queries, and then you'll have some grouping condition and then the ordering by. Right? This is a very simple trick to remember. All right. Again, so what we have done is find all. So we will put star, select star from actor, where upper has somewhere Li, and we'll see where last name has Li, Chaplin, Jolie, Oliver, Willis, all of them have Li. And then we have sorted them by last order by last name and first name. All right. So that's how you can find the you know the wildcard character. Now we'll look at another maybe query which is going to do in, right? So we will do select country ID, country from country, where country is in Afghanistan, Bangladesh, and China. All right. So this is just going to give me the list of, I don't know, this seems a very, I'm just trying to get the country ID of the country. So this just means that I will be able to get country IDs for all of these three. But another way to do is maybe get a group by and get the count of all the actors from that country or movies from that country, depending on the join conditions. I do not know the table join, so might not be something I'll do now. Now, let's just think of changing the table, right? We have looked at a lot of select queries. We'll go to more advanced select queries in a bit, but let's look at changing a couple of things. So if we take a look at select star from actor, actor table is having actor ID, first name, last name, and update date. All right. Now I want to add a description into it also. I don't know. I got happy and I want to add description. The way to add a column in a table, which is one of the key things that you do, is you say alter table name, right? So alter is the keyword which tells the DB engine that I'm altering the structure of a database. Now this is not a traditional command. This is not a select query. This is a powerful query which can alter the structure of the table, right? So proceed with caution. Most people in a production environment, in an enterprise environment, will not have access to do this. You just do selects, right? I'm just explaining. So I have added alter table name, add column, again the keyword, description, and the type blob. Okay, and the table would have been altered. Now if you do a select, you will see a description which has null values. Now you realize that it's almost pointless to insert description for all of these thousands of actors. I don't know how many actors we have, a lot of them, right? So what we want to do is again drop it, right? I want to drop a column. Now if I run the query alter table actor drop column description, it's just gonna drop it, right? And then we'll just see the structure of the table again by firing a select. And you see the drop is gone. Now something to understand is altering a table is a very powerful operation. It's not something you should do all the time. It's not something you should, uh, you know, do without realizing what you're trying to do, because it affects all the rows. If there are 1,000 rows, you're going to add 1,000. The column will come for 1,000 for all thousands of them. So treat that with caution. Now we are going to do a little aggregate operation, and this is where the fun starts. We have looked at select. We have looked at wildcards. We'll look at certain more ways to write queries. And in between, I'm just giving you some thoughts how to write good queries. Okay. So we will list the last name of the actors, and we'll see that how many actors are by that last name, which is probably, for example, in Bollywood, if you want to do right, Kapoor's, right? So many people with Kapoor's surname, like 10 people. So this is a query where you start with that. Select last name, count star, count all of them, and call it actor count from the actor table. If I just run this part, wow, okay, it somehow ran the whole query, which I was not aware. No, it did not. It just did something. Now then what I've done is I've got the last name and I've got the count, and I have from the actor table, and got the grouped them by last name, right? So the count is given by last name and it is ordered by the count, like whichever is the highest, and then by last name. Now this is a very common interview question. What does it mean here, right? So when you have two things in order by, now the first operation determines the first order of sorting. Ascending, descending is not important. First order of sorting. So here it will be actor count sorted from descending, which is highest first. What does last name do? It simply takes the second priority of sorting. So if there are counts which are same, then you sort it by that column. So then it will go by last name. So here where we have all the threes, then it has taken an alphabetical route, and the database engine is smart enough to know if it is a character column, it will take the alphabetical route, numerical will be sorted ascending, descending, etc. Order by, number of columns in the order by are very important. Key thing to remember in group by is group by cannot function without an aggregate clause. For example, if I just remove this and run this query, it will not run. It will fail because there is no aggregate information. Please understand that group by implies that you are aggregating. All right. So we'll keep on moving further. And now we will add another complexity where I only want to see actor count where the count is more than one, because greater than one, right? I don't want these one people, right? There's this, all of these Wilson, Wayne, this just one person. So I will add and change here in last name. Okay, it's done here. Having actor count greater than one, which means the count of actors has to be greater than one in this case. And you'll see there will be no records with one value here. I'm at the bottom, right? Now, let's see. Now we are going to move to update, right? So this is a typo that happened. This is an update that we are trying to do based on a certain condition. So there was an actor called Harpo Williams, and his name was accidentally entered as whatever Groucho Williams. Okay, so we will select first the row, and when you have to do this kind of operation, please remember that selection becomes important, right? So you select the record, and then you call the update clause, which is to say update actor, right, which is update table, and then you say set what, set first name to this and last name to this. After the set clause, you can specify enough number of columns, whatever you want to update, and then you set where condition which matches the select, because you don't want to be updating incorrect value, right? If I don't give this where, it's gonna set everything, which is maybe for fun. We'll try to do that in the end, right? So we'll just run this and then run the select again. And this time we will see that we have Harpo Williams correct. And if I would have just updated just for fun, maybe. Okay, maybe we just want to undo that, right? So we are just going to undo it by just writing the same thing once again. And we will just change back his first name. This is just update parameter, like you're updating and re-updating, whatever. Now, just for fun, if I just remove the first name clause here, I just remove it. So we will, sorry. My bad. Right, so we will just run this. And now everybody will be called Harpo Williams, right? So I've just lost that whole record itself and I've screwed it, which is fine. So now I'm just gonna maybe fire this, and it will not give me any parameter because that name, everybody will be just overwritten, right? So this is why your where conditions have to be very, 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 thought through. Okay. Now we want to just create certain tables again and start using joins. Before I go on start to do joins, just a quick primer on joins, right? You have on my screen a very simple image on what are joins. Now, most of the people get confused by diagrams a lot, right? But it's relatively easy to imagine in the form of shapes like this, Venn diagrams. So we'll start with self join. Self join is the join of the table by itself, which is why it's called self join. Right join is, imagine there's a right table, there's a left table, right? Uh, that's it. This is what is right join. So right join will give you the overlap. Imagine the thumb to be overlapped. So the right join will give you thumb plus 4 records, right? Full join means overall superimposition. Inner join just means the center, right? Which is the only intersection of them. Cross joins means that for each value in table A, we will look at all the values in table B, right? That's what inner join, cross join does. Cross join is relatively not a good thing to look at, and left join is just the inverse of right join, right? And how do you know what is left, what is right? Whichever you write. So if you have written a table on left side, then it's left table. So left table, right table, depending on what you want, you can do right join, left join. And the scenarios can be inverted also. You can, if you have a left table and a right table and you put a left join, you can flip them and try to do the same thing other way around. All right. I went in probably too fast, but we'll go on to explain it. Now, you cannot show, okay. Yeah. Now, if sometimes what happens in database, right, you forget the actual table schema, right? You don't know the table schema. So what you do is you just show create table address, and you'll be able to see the schema for the table. It is relatively not visible beautifully here, so I'm just gonna dump it as export. And this is an easy thing to do. You just click on export and it'll export it. And you can export results. You can export pretty much anything. I have no clue what it exported here. Definitely something which I did not wanted. Okay, we'll just see it probably here. App cell content. Yeah, you can see it here. So this is now giving me all the parameters for table that I needed to see. So sometimes you just want to do show table and it will give you the structure of the table. Then what we are doing is, now what we want to do is use join to display the first and last name as well as addresses of each member. Now remember, address is a different column, staff is a different column, but there is an address ID. So we will do simple, select staff ka sara information, which is staff dot column name, staff dot column name, and address dot, like dot is the notation. And you can do the full name like staff dot like table name dot column name, or you can just give an alias in that query and it will work the same. So it's select statement, whatever we wanted to select. From table, left join the address. Remember, staff is the left, so I'm going to left join on address and get the columns I need, right? Use join to display the total amount run. Now this is where it starts to get complex, right? You're using joins, you're using group bys, right? So we'll extend what we have learned. So select staff first name, use join to display total amount run by each staff member in August. Use table staff and payment. Okay. So I need to do two table join, which is staff table, and get staff information from there and payment information from the payment table, right? So let's just focus on this part first. Okay, so maybe what I'm gonna do is I'll filter it later and I'll show you how to write this query. So the first thing I want to do is I want to ignore this parameter each staff member in 2005. The way, and this is how to think about the queries. That's much more important. So I will put the select, put the from, and then I need to get payment information. So I'm just going to put payment table and join them on payment ID, right? Because, and I will group them on first, last, and last name. And this is a very fine query, right? This query should run, okay? But this query gives me the total information and not the information just for August. I do not know, there's some sort of data screw up. All right, but now I'll just add this parameter and see if the numbers change. Yeah, it changed big time, right? It reduced. So there were two people in the staff table and who received payment. What I did is I added my filters later. Let's just do this. So if I add my filters later, that will just help me build the query. Now, the key thing that I'm trying to teach here is how do you build the query? So you write a part of it first and then you go on adding and filtering it, because filtering can happen at the very end if your query is syntactically and structurally correct. Date filters, amount filters, numeric filter, they can just come in later in the part where you need. So get your query right, the whole structure, and then try to put in filter, right? Now we are going to do a little bit of more different sort of stuff. We are going to be trying to do inner join. Okay, list each films and the number of actors who are listed for that film. Use film table filter and field. Use inner join. Okay, so we will use film.title. This is a relatively easy query. I'm not just gonna ponder over it. We'll move forward. How many copies of the film? Okay, this is again a relatively easy query. You're just adding another parameter. We'll just find a little more complex query. Yeah, right. This is a good thing to do. So we are now doing a sub query, right? We have looked at joins, we have looked at aggregations, we have looked at inner joins, we have looked at maybe wildcards. We'll do a sub query now. Why do you need a sub query? Right, where you want to retrieve an information from a result set. right? Imagine a result set and then you want to retrieve an information from that. You can write, technically speaking, subqueries with joins too, but they tend to get a little more complex, right? So we will do title from film, where title like k, etc., etc., and language in. So if you just run this, you will get a language ID, which is just one, right? There's just one record in this. So instead of putting language ID in, you could just probably have joined to the language table if there was a key column between them. If there was no key column, this is pretty much what you had. So we'll just run it and we'll get all the English movies, right? Similarly, we'll move on to a much more complex query, which is relatively bigger. I need more space to talk about this. So let's say I want to run an email marketing campaign in Canada, for which you need the names and email address of all customers. And what does the query say? Use joins to retrieve this information. Obviously, uh, what is this part? So we will, this is an approach using subquery. All right, you get the email ID and first name, and this is what I was saying. So you first get the country ID, and you can think of the query either way. Both approaches are correct, right? You first build your query in like loops, right? The smallest part first, and then around it, and then around it. And then you probably ran this query, which will give you all the city IDs for that country. And then you got all the addresses for that city, right? And then the problem is very simple. You just look at addresses and think of it that way. So this is one way to write the query. The another way is a relatively multi-join query, right? If you think about it, let's say address ID 481, you get the same information, right? You get this. If I run both of them at the same time, I'll show you. Both of them, query 41 and 42, are identical. The only difference is subquery and joins are just two different ways to approach it. Subqueries make a little more natural sense. People tend to think of them easily compared to joins, because joins sometimes lead to complications. But here all you have done is you have just joined on key columns starting from the base. If you can write a subquery approach, join approach might also work. Performance of the queries can be debated, but with this small query, it's very hard to say anything. All right. And then the query processing gets more complex. I would probably want to stop given 45 minutes are over. So you kind of just increase the complexity of the query slowly and eventually by adding. For example, if you see, this is like a good large number of large query, right? And then this couple of views that we have created, where you have just created, let's say, I want to create a easy way of viewing the top 5 genres by gross revenue. All right. So we wanted to create some sort of a gross revenue stuff. So we have already created a view here. And the view is created, and now you can just run it to see the values, right? You can alternatively just try to run the query every time, but this view will just do the same thing. All right. So that's pretty much the key thing which I wanted to talk to today. And that's how you approach SQL, right? You got to take it step by step. Take a download of the Sequila database, which I pointed out before. You can find these queries on the internet. And with that, all the best. Bye-bye.